first presentation of the ILQ this year. This evening we've got Gary Schofield, who is the Head of Technical at Total Energies. Gary's been in the business and the bitumen industry since 1983, when he started with Lanfina Bitumen. During his employment, Gary has looked after technical, quality assurance and health and safety. Tonight's Gary's presentation will touch on global challenges of bitumen, aging infrastructure of asphalt plants and bitumen storage, opportunities for low carbon material, and the impact of the Russian sanctions on bitumen availability. Thanks, Gary.
So, I hope you can see me all right there, but maybe it'd be beneficial if you couldn't. So first of all, thank you for the invite. I'm delighted to be able to come up and talk to you this evening. And I hope that what I'm going to be talking about will stimulate a little bit of thought, a little bit of discussion. And I hope you go away from here asking one or two questions and really sort of challenging yourselves as to where we should be thinking and where we should be going in 2023. So I thought what we'd start with is a little bit of a SWOT analysis. Okay, so a little bit of a SWOT analysis about where we are in this year. If I can get this thing operating, which is the button I press? The next button. I'll tell you what, we'll go off there.
Wonderful.
So one of the challenges facing the industry is the technology, of course. So whilst Ian's just working his magic, I said before when I was sat down, actually, I'm bloody glad it's Ian sat up here trying to get it working and not me, otherwise we'd be here all the morning. So yeah, I'll put together this SWOT analysis very much from a personal perspective, looking at the industry and really sort of thinking where the industry is going, where it needs to go, but also very importantly, some of the threats that we could be facing in the industry. And I think it's incredibly important for us to be open-eyed and to be realistic about things. So I'll just wait while we do get to the next page.
Don't rely on me, that's for sure.
What did you do?
I have no idea.
There we go. So let's try that now. There, he's got it working. We're doing the wrong job. So, as you can see, I started off there with the strength side, and this is by no means exhaustive. And as I say, this is just from my perspective as to where I see some of these SWOT. So, first thing I've put there is that one of the strengths the industry has is that we have a pretty good, well-established network of asphalt plants throughout the UK. Maybe in Scotland we face a little bit more of a challenge because it's such a vast area. But generally speaking, we've got a pretty good network of plants. However, post-COVID, it has to be said that a good few of the plants have been mothballed and not necessarily come back into action for very good reasons of costs, etc. But I think it's something that we just need to be a little bit aware of. That you know, we're distributing asphalt around the place, and we have to be very mindful of the distances that we're taking things, of the challenges that itself will present. So whilst it's overall a strength, I think there's also that little warning sign there that we've got to be careful, because we have mothball plants and we are in areas we have to be aware of how we're travelling things, particularly the more premium materials, because they do need control. Second thing I've put there as a strength is that we've got rapidly developing bin technology on the contracting side. And I think that is for record keeping and for control on site. I think that is going to be a real boom that will be seen in the coming years. You know, we've said that over the years we've sort of lost that control on site because the REAs aren't on site watching people. But I think bin technology is another step forward, which will really help us to control and understand how we're putting the materials down, but also for future years, understand what has been put down. Because there's a real weakness now when we're going to recycle materials, but we don't understand what's around in most of the network. And I think this will help us significantly. So I see that as a real strength moving forward. And of course, the last point there is that we've already got some good materials which are on the market, and we mustn't lose sight of that. We have good materials, and we need to put those materials down in the right situation so that we can optimize the results we get. In terms of weaknesses and things I think we need to be very mindful of, is that generally in the asphalt side, we've got a vulnerable infrastructure. A lot of the plants that we have are aging. Looking around the room, I could say one or two things, but I won't. But the plant itself is aging, and particularly the tankage that we have. And I think I want to look at that in a little bit more detail because it does frighten me a little bit. I think another weakness that we have is a lack of funding that's coming from local authorities and from the government. When you look in England, Wales, at the alarm survey, we can see the backlog that there is, the underfunding that we have, and I'm absolutely positive that we've got the same picture here in Scotland. And that lack of funding is a real weakness. But I think what we've got to do is, while still challenging the government for more funding, I think we ourselves have to look at ourselves and say, not just ourselves in the asphalt side, but also from the specifying side, we've got to think that, are we doing everything we can to make the most of the money we've got? Are we spending it as wisely as we possibly can? And I think that's the challenge that we're going to have. It's not just about the funding as in pounds, but it's the model of funding that we're getting. We need to have a much longer vision of the budget. So it needs to be a 5-year budget at least, not just a 12-month budget, so that we can properly plan for asset management. And then we can start spending the money that little bit more wisely. I think another weakness that we have is we enter into that period of time where everything's about carbon, reducing carbon footprint, environmental awareness, climate change. In the industry, not just this industry, but many industries, there's a lack of experience in that field. And this talk about decarbonisation is worrying. Yes, it's something we've got to strive to do. Yes, it's something we as a world, as world inhabitants, we've got to strive to do. But how do we do it? And we have a lack of real understanding, I think, of that whole area because it's such a new area. We've got to be very careful. You know, if we're not careful, we jump from one trend to another trend, go wholeheartedly into it, and make a mess of it. So we've got to be very careful and mindful that we have a lack of experience in this area. So we've got to be prepared to learn. We've got to be prepared to take advice from experts. And then the last point there on weakness is something which has really come to light over the last 12 months, and that's import reliability. And what I mean by that is from the bituminous side. You look back a few years and there were refineries all over the UK manufacturing bitumen. That's changing rapidly. And we'll look into that in a little bit more depth as we move on. In terms of opportunities, what a great opportunity we've got for innovation. You know, the local authorities, Transport Scotland, National Highways, at the moment, they're really open to innovation. And I think that's a good opportunity for us where we've got good ideas. We've got that chance now to put it into action. But again, we've got to be careful with it. I think because of the way that we're looking at ourselves as an industry, and because of the way we're reflecting on the materials and how we're using those materials, it's also a great opportunity to review old ineffective specifications. You know, the vision is that we're moving towards more durable materials. And we've suffered in the past from relying on specifications which were developed 10, 15, 20, 30, 40 years ago. And we've relied on those specifications, but they work reasonably well. But as time moves on, we have to evolve. We have to evolve. We have to move with the times. And not just that, but we have to start thinking about what's the situation going to be like in 20 years' time, because the designs we're doing now really are not for today, they're for 20, 30, 40 years' time. So we have to think about climate change and how that's going to impact over that period. And so it's time to reflect on those specifications and start designing for the future. I think the other big opportunity that we have, because of all these challenges that are being thrown forward, is that it opens the door for the supply chain to work better. This has been a gripe of mine for many years, that in this area, we've had customer-supplier relationships, and that's not a healthy situation to be in. We've got to break down those barriers, and we've got to become partners in crime, as it were. And we've got to work together all through the supply chain. So that involves suppliers, it involves manufacturers, contractors, specifiers. We've got to all be singing off the same song sheet. And I think that's a great opportunity that we can move forward with that. In terms of threats, I have a real concern that there could be a significant incident at an asphalt plant at some point in the future. I mentioned before about the aging infrastructure, and it just worries me that if we don't start to really look at our infrastructure, look at our plants seriously, one incident could cause a real problem for the whole of the industry. And we're going to look at that in a little bit more detail. Another big threat is that we get bad procurement decisions. And this is linked to the fact that there's a lack of experience of decarboning, and that if we have decisions based on pure cost at the gate, if we get decisions based on carbon count at the gate, then we potentially could do ourselves a massive disservice and do the opposite of what we're trying to do. We have to think long term. We have to think about life cycle costs in terms of pounds, but life cycle costs in terms of carbon as well. And the introduction of EPDs worries me slightly, because that does open the door for decisions being made on at the gate figures. And that could be the worst thing that could happen to us. So that's a real threat I see, that we could have bad decisions being made. And I think another threat, I mentioned before, a great opportunity is there for innovation, but that also presents a threat, because that innovation has to be properly managed. If we just start letting materials in and processes in without proper control, that could be the worst thing again that could happen to us. So with all these things, you're looking at a balance. You're looking at getting the right control, getting the right opportunities, but it's all about understanding holistically what these processes and materials are going to offer. So I just want to build on that SWOT analysis a little bit. So let's just take that vulnerable infrastructure weakness that I mentioned and this threat of significant incidents. I chair the Mineral Products Association Working Group 7, and that is a working group which looks at bitumen safety in the asphalt industry. And it's something which we're really trying to move forward, because but that group's been around for quite a while, and we've made some strides to contribute towards this improvement in safety. We've produced documents, etc. But we're using figures which have been derived from Eurobitumen in terms of how we're offloading and some incidents that are occurring during offloading, but critically near misses that are occurring during offloading. So that's sort of driving our direction of work in Working Group 7. But during those discussions, we've been talking about tanks particularly and related infrastructure. And there's a worrying trend developing that maybe the infrastructure isn't up to scratch in a lot of cases. Let me just go through it a little bit. We think about tank design to start with. There's a lot of systems around which are pump offloaded. Still the predominance is towards pressure offloading systems, but there's a lot of pump offloading systems around. And it's not unusual if there's a problem with the pump, you know, they'll open the lines and say, oh, just blow it in, you know, we'll just have a pressure offload for this one. Is that wise? Has that really been thought through? Because pump offloading is very, very different than pressure offloading. And the tanks are not pressure vessels. So we have to ensure that there's an understanding of venting capacity versus pressure that's going in there. And very often that's not the case. We've got to think about, during the tank design or during the tank life, have you ever considered desire? You know, when we started talking about this in Working Group 7, the sort of, what's desire? You know, I've never heard of it. And that's worrying, because desire is a very, very important regulation. So it's talking about explosive atmospheres. And in bitumen tanks, in the vapor space, that's classed as an explosive atmosphere. And that's very, very important, because the implications of that are that if you get a spark or a situation where there's an ignition source, then you could be in an explosive situation. And we've seen that in incidents that have occurred. Simple things like, is there a low level cutoff for heating? In other words, if your tank level comes down and it goes down below the heating coils, in most cases that I've seen, there's not an inbuilt low level cutoff. So you could inadvertently take your bitumen down below the heating coils. The heating coils continue heating. You crack your bitumen, you produce very small hydrocarbons, which are just there waiting to be ignited. The very, very basic things. But talking to people on MPA Working Group 7, not all bitumen tanks have these controls in. Is the insulation sound? And what I mean by that is not the cladding, but the generally rock wool insulation around the tank. Because we've seen several incidents over the last 2 or 3 years where there's been fires associated with lagging fires. And that's because there's been spills, there's been condensates which have run down into the lagging. And when you've got lagging, you've got a humongous surface area there. And because it's up against the side of a hot bitumen tank, that thermally cracks the bitumen or the residues that have dripped down there, just right for a fire again. And we've seen many, many instances, and a slight exaggeration, we've seen several incidents over the last few years where we've had fires associated with lagging around tank. And is the cladding protective of the insulation? So in other words, is the design right? So that, for example, at the foot of us, if this is a storage tank that you've got here, is the lagging all the way down? Because if it is, it'll absorb water that comes from rain, etc. That will creep up. And of course, against the hot bitumen tank, that's ideal for corrosion. So what happens is you tend to get corrosion around the base of your tank. If you get corrosion, there's a risk that you can get leaks. And if you get leaks, there's a risk that that could rapidly escalate and you end up with a really disastrous failure of the storage tank. So just simple things like design it so that your cladding, so that your insulation stops 6 inches above the floor so you don't get that water going up there. Or design it so that you have an overhang of cladding so that water runs straight off, sitting on a plinth. Simple things like that that need to be considered in the design of the storage tank. In terms of tank maintenance, I might throw the question out there, how frequently is the tank taken down for inspection? And I'll bet a pound to a penny, most people will look at me and say, inspection? Why do I want to inspect the bitumen storage tank? The reality is that bitumen storage tanks should be inspected on a regular basis. And by regular, I might mean 10 years, 15 years, but it needs to be built into your preventative maintenance plan. Is there a check on the integrity of the annular weld? By the annular weld, I mean the weld at the bottom of the tank. I've got a video, I'm not going to show it now, but I've got a video of an incident which occurred in Russia. And this tank must be of the size, looking at it, between 800 tons to 1500 tons, something of that size. So it's a big storage tank. And it's CCTV that's caught it. And what has happened is that you can see the weld has basically unzipped at the bottom and the tank just implodes. And bitumen, just a tidal wave, a tsunami of bitumen comes out from the bottom. And the tidal wave is something like 30 foot high. 3 people were killed in that incident. And the thought is that there's a failure of the annular weld. Now, obviously, in most asphalt plants, there's nothing like that size of bitumen tank, but nevertheless, if that was to fail, you know, then that could be a significant incident. And I think these are the checks that we should be doing. Is there a check on wall thickness of the tank? So again, when we're talking about corrosion at the bottom, if that has narrowed because of corrosion, we need to do something about it. Is there an inspection of the tank and the lines for corrosion? We've had several instances over the last 2 years where we've been offloading, pressure offloading, and we started to see weeping coming out just where the joint is into the top. And that's because, again, it's corroding. When we've looked at it in more detail, there's hardly any thickness there. And it's been weeps rather than a catastrophic failure, but nevertheless, the indication's there. And if that was just checked every 12 months, you know, just a visual check, that could be picked up in advance. So it's about putting in place preventative maintenance to be looking after these things. Is there a check on the heating elements? Is there knowledge of the dimensions of the tank currently? Now, what I mean by that is we've had several instances this year where gauge readings have been incorrect. We've ended up spilling, and the gauge has been something like 5 tons out. When they've inspected, they've found that actually that difference is being caused by carbon buildup in the tank. And so it's important. People underestimate the amount of carbon that can be developed in the tank. And so if you don't take account of that in your tank dimensions, you're going to get false gauge readings. And of course, we talk about safe working capacity being 10% of the, being 90% of the overall capacity. Well, if you're then suddenly reducing that down by another 5 tons, all of a sudden you're filling it up and it's coming over the top. So, you know, that understanding of current tank dimensions is critically important. And then are the thermocouples checked? And the reason I put that in here is we had one example where the tank was turned on, the tank get heating, and it didn't cut off. And when they did an investigation into it, they found that the on-off switch had been welded together. And it's just basic things like that. You think, how can that happen? But it does. You know, and that's so important, therefore, for us to take a step back occasionally and start reviewing these things. In terms of tank cleaning, how often do you clean? Has it ever been cleaned? You know, and I know many plants where the tanks have been in for 20 years, 30 years, and they've never been cleaned. It's important, not only for how much volume there is in the tank of ullage, but also, is there an understanding of risk of pyrophoric deposits? Pyrophoric deposits really are carbon deposits which can become self-heating under the right conditions. And if you get that, there's your ignition source. Yeah. So then I remember an incident many years ago at an industrial plant, and it was a square tank, and it was a oxidized bitumen, so it's quite a high temperature bitumen. But I remember them ringing up and said, "It's out of spec, this stuff. Can you take it away?" And sure enough, we tested it, and it was out of spec. We started to draw material out of the tank, and there was a humongous explosion. The lid of the tank ended up in the yard of the company next door. The guy who was stood on top of the tank at the time ended up on the floor, and he never worked again. And the reason for that was the tank had never been cleaned. So there was carbon in the tank, but it was either pyrophoric carbon or it was pyrophoric iron sulfide. And these are materials which can build up over a period of time. And of course, they had electrical heating in there with insufficient agitation. And the thermocouple was up here, the heating coils are here. And so that the thermocouple was saying, I need more heat, I need more heat. And because there's no agitation, bitumen's a poor conductor of heat. So the heating elements were just getting hotter and hotter and hotter. And around the, we believe around the heating coils, that temperature was probably 300 or 400 degrees. And it just started to firmly crack the bitumens, producing volatiles which sat in the vapor space. You've got these pyrophoric materials on top. And as soon as we started to draw bitumen out, we completed the fire triangle. We drew air in, boom. And like I say, that poor guy never worked again. How often is there inspection of the level of carbon around heating coils? Because again, it's the heating coils. If they can't transmit the heat out, they're just going to get hotter and hotter and hotter. Not only is it dangerous, but it's bloody expensive because you're spending a lot of wasted money on trying to heat the stuff up. And just that understanding of how much carbon can collect in a tank, it can be significant. So it's important that we consider these things in our preventative maintenance. In terms of tank control, are there sufficient temperature gauges well positioned? You know, it might be that you have 2 or 3 there, so you understand if you're at different levels, what the real temperature is around the tank. Are storage temperatures well understood? And are we storing them at the right temperatures? Is there agitation in the tank? Now, generally, I know there isn't agitation in the tank. Ideally, we would have agitation because what you want to do is take that heat and spread it around. Don't, you know, it's not great just relying on radiating heat out. It's much better if we can agitate it. And again, I'm not saying we should go retrospectively and start putting circulation on all the tanks or mixtures or whatever. But if you're putting in new tankage, think about these things. Are safety integrated systems in place and checked? This is really important when we're talking about pump offloading systems. We had an inordinate number of spills on pump offloading systems at one point, and they're supposed to be much safer. And the reason we had problems was because they hadn't been properly designed. So they had cut-offs which were ineffective. They weren't failing to safety. So for example, there was one example where we had a spill where there was something going wrong. So they pressed the emergency stop and it just cut the electric to everything. Didn't shut the valves. So it ended up that bitumen was just siphoning out of the tank. So any system that we have, particularly which is like a pump offloading system, we must have a properly controlled, staged cutoff so that we shut the right valves at the right time. And it's got to be properly thought out. And the only way we can do that is to do effective hazards and HAZOPs. So hazard and operability studies. What they are basically is a really controlled risk assessment. So you ask the question, what happens if? So this is normally done at the design stage, but we can also do it retrospectively. So you ask the question, what happens if this occurs? And you work through the system. You look at what controls you've got in place, and if they're inadequate, then you put more controls in. And it's a little bit like layers of an onion. You start to build up control layers. But the HAZOP and hazard is hazard identification, and then HAZOP is hazard and operability studies. Please, I would recommend that you all start to look at that in your companies if you're not already doing it, because there's really useful technique to avoid incidents in the future. In terms of tank movement, in other words, if a plant is mothballed and you want to move your tank to a new place, treat it as a new tank. Go back and do a HAZOP study on it. Inspect it properly. Has the safe working capacity been recalculated? Because if it's an old tank, it's probably got the inches and inches of carbon in there. Replace the lagging. Strip the lagging and replace it. I've seen incidents over the last couple of years where this very thing has occurred. And I even saw an example where the tank had been reclad, but they'd reclad it over the old stuff. And the problem is that the old stuff had absorbed oils over many, many years. And guess what? A lagging fire occurred. So there's no shortcut to this. And again, ask the question, has the tank been cleaned? Has the integrity of it been checked? Very, very important. So I realise I've spent a little bit of time looking at that, but it's so important that we've got to up our game, I think, as an industry, got to up our game with regard to the infrastructure that we've got in our tanks. The second thing I wanted to look at was this question of lack of experience of decarbonising and the great opportunity that we've got through this decarbonising area. and there's concern about bad procurement decisions. Let's just have a little bit of a discussion on that. There's an awful lot of talk these days about this move to net zero. What the hell does that mean? You know, again, it's this generic term that people are using, and it sounds great, but what does it actually mean? I'm sure that different people apply different meanings to it. People talk about decarbonisation, and we've been asked many times, what are you doing to decarbonise your bitumen? Well, what do you mean? I mean, bitumen's a hydrocarbon. You know, it's but don't demonise it because it's a hydrocarbon. You're not burning it. You're not releasing CO2 into the atmosphere with it. It's an engineering material which is a hydrocarbon. Oh, we don't want hydrocarbons. Well, I suggest you get rid of you and me because we're hydrocarbons. You know, and it's understanding that hydrocarbons are demonised without really thinking about what you're saying. So decarbonisation is has got to be, that terminology has got to be used wisely. And I think there's a complete and utter lack of clarity as to the way people want to move. National Highways have been set up this working group to try and look at journey to net zero, decarbonisation, and they admit themselves they don't really know they don't really know where they want to end up. They don't really see what the big picture is. They just know they've got to do something, and this is the problem. We know we've got to do something, but what it is we're supposed to be doing for the best is very difficult to quantify. And again, this question of EPDs, environmental product declarations, frightens the life out of me. You know, this is where we're going to be submitting to you guys effectively the cradle to gate figure. It's important that we then think about what happens once it's gone to the gate. So we talk about then the lifespan of it, and then about the recyclability of it, because carbon counting, monetary counting, can't just be based on the cheapest or the lowest carbon at the gate. If you make the decisions based on that, everything's going to be basic asphalt, the cheapest asphalt you can get with the lowest bitumen content. The reality is, of course, your durability is going to hot in that instance. So in effect, it's going to cost you a lot more because you're going to have to replace that surface course, for example, every 5 years instead of every potentially 15 or 20 years. So we've got to make sensible decisions and not just at gate figures. But it's not even as simple as that, because the environmental challenge is not just based around carbon count. You know, we do become obsessed with these individual things, but it's not just based around carbon count. It's based also about what we're doing with regard to resources. So what do I mean by that? Let's think about recycling. And if we recycle really effectively, we'd be taking the surface course and segregating that out, because we've got really useful finite resource in the aggregates on the surface course. So we should be really separating that out. Just turn the aggregate around a bit and it's as good as new. And so we should be using that to real good effect. We're talking about polymer modified bitumens in surface course, and we're now recycling that. We should be looking to extract as much value out of that residual bitumen as possible. And also we're making the most of the recycled element. And by doing that, we're going to save resources up front because we're making more use of what's already there. Water and biodiversity, another impact that we've got to think about. People keep pushing me to say, what are you doing about biobitumens? What are you doing about biobitumens? Well, I've got to say my company is looking seriously at it, but we're still not fully convinced that it's necessarily the right way to go. Why do I say that? Well, if we're growing fields and fields of plants to supply into bitumen, are we actually taking away fields which will be better utilised to supply food? We're already knocking down the thousands of square kilometres of rainforest in order to grow food. So we've got to ask the question, what's the best use of that land? The other point, of course, as well, is that if we're growing crops which are not normally there, what we're doing to the ecosystems. Yeah, and these are the questions that it's dead easy to jump on the bandwagon and, oh yeah, well, we can do this, we can do that. But we've got to think about the holistic picture, not just the short-term picture. So I'm not saying that bio-bitumens are wrong. I'm not saying that they're not the way forward, but the selection has got to be right. And we've got to think about the holistic picture of that. So we talk about that this gives us a really good opportunity. This striving towards a more environmentally friendly solution gives us a real good opportunity for innovation. And I think the time is right for innovation to be used. And if we talk about moving from an innovation idea through to a trial situation, that brings one thing, doesn't it? It brings risk. There's nothing wrong with risk, as long as that risk is well managed. And what do I mean by that? Well, effectively, it's about understanding the full picture of the material or the process that's to be trialled. We just talked there about looking at the holistic picture, and it's exactly the same here. We need to understand the full picture. We've seen many examples over recent times where the green flag's being waved, and this is new material. Look at all this stuff in the oceans. We can put this into asphalt and it increases stiffness. Well, increasing stiffness is fine, but what's it doing at the other end? You know, generally there's a compromise to be had between stiffness and fatigue, or stiffness and capacity of the material to relax strain. So look at the overall picture. Asphalt has many dimensions of performance, so we need to understand each of those. We've also got to ask the question, what's the implications of that on durability? So I remember Colin Loveday many, many years ago saying that, we're not producing trash fault. The road isn't there to put any old crap in. Because of course, over the past years, we've looked at glass, we've looked at this, we've looked at that. Some have worked, some haven't, all right? But the key thing is the road isn't a linear land dump. It's not that. It's an important engineering structure that we have to take care of the durability of. And we need to understand we must not compromise the durability. Very, very importantly, and again, this is where the supply chain link is so important, that we've got to understand the limitation and performance of these materials. Us as suppliers, if we're going to introduce new materials, we've got to be honest to say what the limitations of performance are. No matter what, nothing is the silver bullet. We might have benefits in certain areas, but it's equally important to understand the limitations. A classic example is thin surfacings. We've pushed and we abuse these systems until we end up at failure point. And if we control it better, we're driven, unfortunately, by pushing things to the limits, which is great as long as we don't go over those limits. And so as individuals, in terms of companies, we have to understand where the limitations and be honest about those limitations. At the end of the day, if I'm supplying materials to you guys and I'm trying to push, this is great, this will work, don't worry. If you have a failure, that's not going to benefit me at all. It just makes a mockery and ruins my reputation. And that is my concern, that at this time we've seen several people coming in with these great ideas, flag waving, hitting the local authorities to be saying, this is the answer, this is the environmental solution. And the problem is that they can ruin opportunities for genuine companies to go in and put true innovations in. So we've got to be very careful, we've got to be well managed. So once we've taken all those things into consideration, then and only then plan a proper trial or validation, and we've got to have planned monitoring throughout. So the supply chain has to work really, really closely together. So when I talk about durability and those EPD figures, just wanted to show this as an example. So if we consider the design life of the road is year long, let's say it's 50 years. And you've got designed surface course interventions every period like that. Okay, the cost in terms of carbon is X for each of those interventions. Okay, if you had a material which lasts longer, but it has a higher carbon count at the gate, so let's say the carbon count is 1.3x, that sounds very unattractive. And the chances are that the procurement will say, no, the monetary costs are too high. The carbon cost is too high. But if it lasts 50% longer on the road, then all of a sudden we move from 5 interventions, maybe to 3 interventions. Then you start comparing the life costs. So for the red example, the total carbon cost is 5x. For your green example, it's 3.9x, which is a saving of 22%. And I think this is the way we've got to be thinking more and more. There's a great example in Holland of a site that was being procured, and the local authorities went with the lowest carbon count. So it was a thickness design like this, and it was with penetration grade bitumen. So this company went in and said, if you use PMBs, you could reduce your thickness this much. So although the actual asphalt itself will have a higher carbon count, you'll actually save because you're putting less of it down. So, and what's more, it'll actually last longer once it's down on the road. So again, that holistic overview and that full understanding, that's got to be a challenge for us for this year. Because without a doubt, durability is one of the keys to sustainability. If you get it durable, that's make it last, do it properly and make it last. That's one of the best approaches to sustainability. And I think that in terms of these opportunities for innovations, I think we'll see more secondary recycling coming in. I mean, as I say, we've already seen some historic examples such as glass. I remember we were talking earlier about the M40, where they were talking it's being paired with mills and booms because they were using paper from books that had been shredded, and that was the cellulose fibres. We've seen plastics already being used in secondary recycling to greater or lesser success. Lesser. So beware the greenwash. You know, understand the full picture. And I've got to say, my bit of marketing coming up, in Q2 this year, we're going to be looking at launching a significant new product. I can't tell you too much about, but it will be based around secondary recycling. And we believe it's got some real benefits in terms of the whole holistic picture of the material. And that's the key, that whole holistic picture. And then finally, I just wanted to pick up on this question of import reliability. What do I mean by that? Well, again, this opens the door for supply chain to work better together, because producing this honesty, this transparency, this working together. Again, I mentioned earlier, if you go back sort of 15 years, there were several refineries in the UK that were refining down to bitumen. We're now in a situation where we have Lindsay Oil Refinery and Easton producing bitumen. And there was an article that came out recently which suggested that come Q2 or Q3 in 2023, Lindsay Oil Refinery will be no longer producing bitumen. So that leaves one bitumen refinery in the UK. That means that we've seen this massive transition from home-produced bitumen, if you like, to imports. And that puts us in a very, very different situation. So that now the UK is massively reliant on imports. What's made the situation even more complicated is the Russian sanctions. Of course, we know that the war in Ukraine has created massive issues for many areas of business. In terms of the bitumen, something like 50 to 60% of bitumen that was being produced in Europe was using a significant amount of Russian material. You take that out of the equation, people are scrambling around thinking, oh my God, we've got to completely relook at this. What do we do? And this has been a transition year. 2022 was a transition year where people have been looking for these different sources of material so that they can produce bitumen. But what it's meant is that effectively there's been a bit of a shortage around the place. Couple that with the lack of shipping that's been around, and it's become a real challenge. So I think 2023, I mean, what I've put there is a map of what we have as total energies in the UK, all now based around import facilities. And this has been a real challenge for us, a real change for us, because we used to have our own refinery over at Lindsay Oil Refinery, where we used to produce all our own bitumen. We then sold that to Prax several years ago, and we started to look at the import terminals. Now we're going to be completely reliant upon import terminals. And we have the fortunate situation in which we can use our own European refineries as much as possible. But the reality is we won't just be relying on our own European refineries, we'll be buying from third parties as well. And it's controlling that. So what that means is gone are the days where you used to have consistent supplies from exactly the same crude source material. That's changing. So we're going to be having more variability. There'll still be compliant to EN 12591. You'll still be buying the same specification material, but it might be slightly different in the way it behaves. Still good for asphalt. The real challenge comes for people who are modifying it, people who are emulsifying it. That's where the real challenge comes. And so it's going to be a real challenge for the industry. As I say there, it's relevant, really relevant, that for specialty products. And so it's something that we have to just be aware of. So to summarise, what we're saying is that overall, we've got a reliability of current infrastructure question. Please, I would ask that as an industry, we need to open our eyes to this and really start to look at it in earnest. And if we're building plants, we need to be building for the future so that we do proper design, we do proper preventative maintenance planning. We've got to ask, how do we address climate change? And we've got to be concentrating on facts over marketing. Don't just rely on the likes of me coming around and spurting BS. Let's see the facts. Let's see the facts and the figures. We've also got to make sure that our thinking is long term. If we just think short term, and this comes to local authorities, this comes to the government, we've got to start, as I said before, looking at longer term budgeting so that we can do proper asset management. And if we do proper asset management, then we can start to design for these longer term sites. And until we do that, we're going to struggle. We're as we say, we're running through mud. And final thing that we've talked about is bitumen imports. The UK is now reliant on bitumen imports, and we're in a very different situation. That shouldn't affect asphalt too much, but it can affect those speciality materials, such as emulsions, such as PMBs. So again, it's important that when you're asking for PMBs, understand the performance that you're going to get, because that's what's critical. I've said many times, PMB, it drives me mad when I see a specification and say, oh, it's PMB. We need to start specifying what we want from that PMB, because until we do that, you don't know what you're getting. Okay, thank you very much for your attention. I hope it's just stimulated a little bit of thought, stimulated a few questions for now or for future. So thank you.
Any questions for Gary?
I've got more of a statement. The opposite of what you're saying, how are we going to change clients' perspective of it? Because in the last year, the cost of making a ton of asphalt, through buying costs, etc., has gone up by 10, 15 pounds a ton.
Yeah.
Which means the client's got less budget, so he gets less tons for his money. And we're trying to persuade him to do more tons to do less in the future. And that seems a cycle that's going to be very, very difficult to bring. And the second point is, you're absolutely right with Russian bitumen. The clients at the moment are sending out questionnaires to companies to demonstrate that they've stopped buying from Russia. For more interviews with companies about, so it is quite a technical thing.
Yeah. I think your first point there, Alan, is very well made. I mean, you were the head of the AIA for quite a period, and we know the challenges that we're faced with the government to try and increase the funding. And there's no doubt that the problem is that the AIA were very successful in raising the profile of the road structures, the road networks, and the state of those networks. The problem is that it's become fixated on potholes. And of course, now a local authority is judged on how many potholes it fills in a year. And that's the type of thinking we've got to work as an industry to break that cycle. And there's going to have to be difficult decisions made, I think, because there's going to have to be roads which are sacrificed. And because we're addressing, it's a little bit like the bird's pyramid, you know, for safety. At the moment, we're focusing on just making safe the roads which are in a dire strait. And all the time we're doing that, there's decent roads which are falling into the poor states. Sooner or later, we've got to say, we've got to stop that middle bit happening. We've got to protect that at the expense of some of these. That's very easy for me to say. For a local authority that's faced with that cyclist who's just been killed recently by going down a pothole, none of this is easy. But sooner or later, unless we break that cycle, we're just going to continue to go down, because as you say, we're going to be doing less and less. And the danger is that we look to do more with less money. And that means that we're doing things on a short-term basis. The only effective way to do it is to, you know, do these things, stop the good roads going into the bad, and do them in a way which will make them last a lot longer. But that's very easy to say. But the only way we can do it is to work as a supply chain and work together with these things, because all the time we're fighting, it's not helping. And the government, I think the AIA has very much got to move to a change of emphasis, shall we say, because we keep asking for more money, which is we need more money as an industry. But look at it from the government's perspective. NHS needs more money, social care, education, they're all shouting for more money. The reality is we ain't going to get any more with the situation we're in as a country, with the borrowing that we've got. So I think what we've got to do is change that message and say what we've got to do is start to look at spending it more wisely and budgeting more wisely. So let's do more with the money we've got effectively. Yeah.
In view of the shortages that you say are going to happen, is there a future for more surface dressing to take over and reduce the amount of asphalt surfacing that we use?
I think with all these things, we've got to look at using horses for courses. Surface dressing is a useful tool in the toolbox of the local authorities. And I think if surface dressing is used correctly, and again, it comes back to using the right process at the right time. Surface dressing should be used before a road, before there's anything that looks wrong with the road. In other words, you know, before we get to significant cracking, we should be applying surface dressing. The problem we have is that most surface dressing these days is being applied on roads which are significantly cracked and which are actually knackered. You know, so all that does is effectively waste the money. So again, it comes back to spending money wisely. I remember several years ago, we're going to look at some failures, and you know, our customer was saying we've had all these failures. You know, it's material. When you looked at it, it wasn't failure of the, it was probably 6 inches down where the failure was. You know, and that's the problem, that these processes have to be used in the right situations. Otherwise, we get the process itself gets a bad rep, and it's not there to replace hot mix. It's there to protect the road before it gets to a certain situation and extend that life. And I think we need to sort of get back to that real situation. It's not to patch and mend, it's to prolong at the right time.
There's no structure really at all.
Absolutely, absolutely not. It seals the surface.
In the 70s and 80s, Prince used to weigh 3/4 table fire all the roads, and 4 months later, when the surface dressed the new road. That was it.
Yeah.
Companies lobby for 10, 15 years.
Yeah. Yeah.
And
And
now,
it's,
as you say, we're covering up other problems.
Yeah. absolutely. Yeah.
I have another big question, and I'll be honest, I don't think anyone in my company has ever cleaned out a bitumen tank. I might be wrong. I don't think I'm wrong. And it's also obvious by certain bitumen's that there was more carbon than tanks from, say, one type of bitumen to those from another. But I have no idea how you would clear out a bitumen tank and get rid of the carbon. How does that happen? Could you tell us?
I mean, to give you an example from what we do at Total Energies. So we've done risk-based assessments on how we need to clean tanks. And a large part of that comes from reviewing incidents around the world that have occurred in bitumen storage tanks. And so you look at the different incidents that have occurred. There's a great document out where it lists something like about 80 incidents around the world, fires, explosions, etc. A bit worrying reading, but nevertheless, it's very valuable information there because it gives us a real steer as to the sort of things that we've got to be avoiding. So that's one of the key feeds into HAZOPs when you're designing storage
This
tanks.
is an easier one, isn't it? You've got 60-ton tanks doing 42 tons.
That's a real good indicator.
As to how you get that 18
Yeah.
tons out of it.
Exactly. Well, what we do, we open up our tanks every 10 years. Okay, so big tanks. We have to, what we do, we have to scaffold, clean it out, empty it out, obviously make sure it's all properly defumed, etc. And then pretty well go in and water jet it out.
I guess that's a lot easier to do in a refinery than it is to do in a quarry.
It's bloody expensive in a refinery, I can tell you
I'm
that.
sure it is.
Yeah.
I think that's part of the problem.
It is.
2 to 3 tons from quarry, how do you shut them down?
Absolutely, absolutely. And it becomes part of, that's why it's planned preventative maintenance, so that you can plan for the event. And I mean, at our place, we have to cycle it around, so we would change what's in each tank. We haven't got a plethora of tanks at Preston, but we have to just plan, and then we take it out, we clean it, we fully inspect it, do any repairs that are needed, put it back in service. And that's done every 10 years. I mean, with the MPA Working Group 7, we're just working on a document now, which is what constitutes a good bitumen tank. So in other words, it's about design. And what we're not going to do in that is tell you, you need to do this, you need to do that, you need to do that. What we're going to say is, you need to consider this, you need to consider that, because we're not engineers, but we can only point the industry in the right direction for what you need to be considering. The follow-up document to that was, what does a tank inspection look like? And how do we clean out? So these are the things that we're going to try and develop so that it gives at least a little bit of guidance to the industry to what we should do.
I guess you've also got to make sure the manufacturers are aware of what the industry should have.
Absolutely, because just to give you a little bit of a sort of scene setting, the discussion started by looking at these incidents and saying we need to talk to the tank manufacturers. And then we sort of took a step back and said, well, how do we discuss with the tank manufacturers? Well, the first thing we need is to say, what does a good tank look like? So that's why we're doing this. And then there's part 2 of the plan is to then get as many of the tank manufacturers together and start talking to them. Because they have a duty of care when they're designing their storage tanks to make sure that they put the right systems in. I was talking to one of the guys on WG7, and he was saying he procured a tank. And then when he started talking to them, the tank arrived. He said, there's no cutoff, no low temperature cutoff. To which the tank manufacturer said, well, that's extra. But surely to goodness, that's a fundamental safety. And it just baffles me.
But it's the same with war machine. We have, I think, 18 or 19 different extras onto the other machine.
Yeah.
To my mind, those should be specified.
Absolutely.
Should be charged and specified them properly.
And that's where I think the HAZOP comes in, because at the time of design, we should be doing these HAZOPs and looking at the what-if scenarios. And when we go through those what-if scenarios, that tells us what we need to be putting in terms of layers of protection. And it's a really useful tool, not easy tool, but really useful. And it's something which is absolutely biblical within Total Energies. Anything we do, even the smallest job, we do a HAZOP. So.
Okay, well, if there's no more questions, thanks, Gary. It's pretty.